In the earlier class, we discussed about set and the operations, different operations on the types of operations we use in the set. Okay. When we deal in mathematics, normally we deal the numbers. We deal with numbers. Am I right? And those numbers are often they are the real numbers. Most of the time we deal with the real numbers. Okay. So that's what the real numbers means. What the real numbers extends from in the number line. It takes all the rational, irrational numbers, all the numbers, and from where to where? Yes, minus infinity to plus infinity. So this real number contains the entire domain of numbers, entire range, the numbers which we are going to deal in our mathematics. And when we define a set, we won't use a minus infinity to plus infinity. We take a small portion and that numbers we deal it. Okay. So for example, so you say the age of the humans. So age of the humans, you don't go from minus infinity to plus infinity. It goes from 0 to at a maximum 60. Okay, people don't die at 60. People die even at 100. So put it 150. Okay, or in the worst case, put it 200. Okay, unless until you have the man from Earth. He lives for 200, 300 years. So we don't have that. Okay, so this is a range. Okay, and otherwise you will see that suppose for example length of a highway, it cannot be larger than the radius of the Earth. Okay, a length of a road. Okay, there are many things. The length of a pen. How much should be the pen? So there is a fixed number range you will have. Okay, though number will be a real number, but the length can be an fraction. Okay, the fraction. But of course, even though it's a fraction, you don't go from minus infinity to plus infinity. So then what we have in most of the cases, when we are dealing with the numbers and everything, we take a small set of numbers which is defined which is well within our real numbers and deal with that numbers. Okay, so that small region of numbers, or what I call it is an interval of numbers. That's what we define as an interval. The number within which we actually deal, that is the only number which is essential for our entire study. Okay. So how we do it is, so for example, so what will we have? So suppose we are having let us go for the age of the humans. Okay, age. So if I want to write it in the set builder form, what will I do? Age is the form x such that x is an element of first real number. Okay, age can be a fraction also. You can be 1.5 years old. Okay, 1 year and 3 months old. 4 months old, it can be a fraction also. Okay, so if you want to calculate the date, then it can go for the fractions also. Okay, so so this will be a real number, and then what will you have? X, will it from infinity to minus infinity? Age, first of all, age cannot go less than 0. Okay, because there's nothing like a human started with a negative age. Okay, so we know x should be greater than 0. Okay, and then x should be, will a human have an infinite age? No. Okay, maybe something around say 200. 200 is a limit. We find no one survive beyond 200. Okay, so can a human have 0 age? No. Okay, and similarly, so this one 200 also will not have. So this is the way. So then you define, this is what you call as the interval. Okay, this is what you call as an interval. And many times, interval is not always less than 0. For example, we can say, suppose the age of the children who are studying in 11th standard. Okay, it may be a very small range. Okay, it may go from 16 to, or maybe 15 to 17. Okay, or age of the student who are studying higher secondary, 11th and 12th. Okay, then it will be 15 to 18. Okay, so in that case, what happened? Let me call, so this was an set, I will call it as A and let me call B. That's the age of the students who are studying 11th and 12th standard. So X such that X is again that's a real number, and X will probably it will include the age 15 and it may include the age 18. Okay, so there what happened. So here it doesn't, here I won't have any 0 means there's no age, right? So they may not include. Okay, there it is, it may not include. Here I may include the students with the age 15 or 18. Okay, so this is also an interval. Okay, suppose I'll ask you a question. Okay, so let us put up the question like fine. So suppose the age of the babies till they go to school, first school. Okay, the babies who are not went to school, first school. Okay, so in that case what happened? Again you will have something like, you know that at 5 years, maybe some children may go at 5 years, some children may go at 4 years, some children may go to 3 years, some children may go at, because some children straight away go for first standard, means 5 years. Some children may go for kindergarten and all. Someone will go for a play school. Some very sensible parents from the day baby was born, they will start teaching. Okay. So in that case, so what I will do, so you can have, so in that case I can have another set. The babies who has gone to school, okay, who are not gone to actual school. So in that case, C will be such that X is an element of R, and I will say beyond, say maybe at least at the age of 7 they should have gone. Okay, so I am going to put it as, okay, so let me see, we are at 5. Because let us say after first standard, suppose nobody is allowed to go to school. So by 5-year age, there's a limit. Okay, and now what will be here? X will be greater than 0. Can it be equal to? No. It won't be equal to, because 0. So here again, this is an. So here this type of equation also we will have. So similarly, some other notation will have here it will be equal to, but here it will be lesser than. So this is the relation. These are the relation symbols, or the means inequality symbols. This is not equal. Okay, it's unequal. Okay, because greater than or lesser than. So these are the typical symbols. So this is, so here also this defines an interval. So an interval can be defined in different way. Sometimes the interval I take between the two extremes, these are the two extreme points, and the interval, the range of X I am going to use may not include the extremes. It will take the extreme up to or from. Okay, but it won't include from that number or up to that number. Okay, on the other case, there are times it may include that limit also. Sometimes it may, at one point it may include, the other limit it may not include. So this, then the interval, even though I call them interval, the interval can be classified into different types of interval. Okay, so then how we are going to classify is, so first let us write what you call as a, when the extreme points are not included, okay, then you call that interval as open interval. Okay, so open interval, and in general, how can I write? So let me call the interval BA, which is equal to X, such that X is an element of real number, okay, and maybe some A, X is greater than A and less than B. Okay, and the way we notate, how do we, the notation used for this open interval is put a parenthesis and then put A comma B. Okay, and you can represent, these all things can be represented in a number line. Am I right? These are numbers. You can have a number line and you can represent everything in a number line. We have done it earlier, number lines, right? So then what? So, so in number line, how are we going to represent this open interval is, say for example, this is A, okay, and this is B, okay, and your X includes all the values in between. How do you represent? Suppose A and B is a open interval. Is you put a open circle. Okay? So then the interval is what? Interval is in between these two. Okay? So this is what? Our open interval. So now, so when the interval includes the extreme points, which includes, so then you call that interval as what? Closed interval. Okay? So closed interval is what? So then you write closed interval. Say something like B, which is equal to X, such that X is an element of R and A is less than equal to X is less than equal to B. So how do we represent symbolic form? Square bracket. You got it? So you see the difference. When you have parentheses, that is open interval. When the moment you add up a square bracket, then you call that as a closed interval. In the number line, how do we represent? So here it is A and this is B. In the number line, you make it as a solid dot. Okay, when the solid dot, then you call this as your closed interval. Okay, so this is what we have call about a open interval and a closed interval. Now we have one more. That is this. Okay, now here you get two types. Either this is lesser than equal to or X is greater than equal to. Either of the case. So this get divided into two types. Am I right? Okay, and then since it is only half, so we call it as a semi. Semi. Okay. Now we want to call it a semi-closed. One type we call it as semi-closed, and another one we call it as a semi-open. Okay, so which one we call as a closed and which one we call as open is the left side, the lower limit. If the lower limit is closed and upper limit is open, upper limiting is open, then you call it as a semi-closed. Okay, semi-closed is what? So suppose in our case, AB, what happens? Semi-closed will be like A less than equal to. This is a closed and this is B. Semi-open is what? A less than X, because left side should be open. Equal to B. So this is what we call as your semi-closed and semi-open. Okay? Okay, so you should remember these things. Okay, so now let us write down. How do we write the? So then we can write down this semi-closed and semi-open interval as. So now tell me, how will we write down the semi-closed? Okay, let us write semi-closed. Closed interval. How do you represent semi-closed interval? So let us say it's C. Tell me, X such that X is an element of R and then
A, which is less than or equal to X, which is less than B.
X is less than B, X is greater than. You should call A. Okay. Okay, our variable is X. Okay. So what is the symbol? Can you tell me how we are going to write it? From the left hand side, it is closed.
So that
So you
left
put
will be dot. Solid.
square bracket. The symbol I am asking.
Oh, that,
Closed. Okay. Then A, comma B. The right hand side
Open.
is closed.
Curved bracket.
Okay. It looks funny. Okay, but it's very right. Okay, so in the number line, can you tell me what is the very right?
A will be black, right?
Correct. A will be a black
Solid.
dot and B will be a open circle. Okay. So then this is what our interval is. Okay. And then now can you tell me what is semi-open? Let me call it as D. Tell me what it will be. I removed it. Yeah.
So in brackets
X.
x such that x is an element of real numbers.
Okay, good.
A is less than x and x is less than or
X
equal
is greater than A, not A.
Oh,
I should
yeah.
say. Huh? X is greater than A
and
and X is less than or equal to
b.
B. Okay. And how do you represent symbolic form?
Curved bracket A
A.
and B closed bracket.
Square bracket.
Square bracket.
Okay. So that's it. And the number line also you can do the same way. You know what to be written. Yeah, basically this will be a circle A and this will be a
Solid.
okay. You got it? Yeah. And okay, yeah. That's the one thing is written is so here A is an element of C. Am I right? Is B element of C?
Yes.
Is B element of C?
No. B is not an element of C.
Ah.
It's not an-
Yes, then okay.
Uh,
Or okay, either they will write it as a linear symbol. So what you write it is A is an element of A, comma B, and B is not an element of A, comma B. Similarly here, A is
not an element.
not an element of A, comma B,
B is
so
an element.
B, and B is an element of
A comma B.
A, comma B. Okay, so that's what your the interval types are. Okay. Now tell me, how will you construct a set of all real numbers? Okay, so what set of all real numbers? Say something like your set A will be X such that X is an element of R. That's it. So real number can go from to minus infinity. So now you tell me, is it closed or open? Infinity.
You can't reach the
Yeah,
infinity, so
correct.
it'll be open.
It will be open. Very good. So infinity is open. So suppose for the set of all the real numbers, if you want to represent, what will you say? Minus infinity to plus infinity. Correct? This is open. Okay. In a number line, how do you represent? Can there be any dot or circle? No. Okay. So just two arrows only. Because it takes the entire number line. Okay. Now tell me, suppose I want to know, okay, let me write another one. So B, which is X, X is an element of R and X is greater than A.
8 infinity.
So what will be? Tell me.
X is greater than A, right? So A to infinity. Right?
A to, so yeah, the same thing, no? Because you can write it as, yeah, so this how will you write it? A is, X is greater than infinity, infinity. Am I right? So this will be A, comma, infinity. Got it? So now tell me, in the number line, how it will become?
1 point and
It's a closed or
open.
open, yeah. At A, it will be a open circle and then it goes infinity. Correct? So that's what your this one here is. Okay, so usually they show it as an arrow. That's it. Yeah, fine. And now, so now this is for the. Now let me take another set. B x such that x is an element of R and x is greater than or equal to A.
It will be the same, but it will be closed.
Yeah, where?
In A.
Yeah.
A will have a square bracket.
Correct?
Oh.
And then infinity
Curve bracket.
curve bracket. And here, this will be the same thing. Only thing it will be a solid A. Okay. So same way we can do it for less than also. Okay, so let me call it as D. Correct, exactly. D will be equal to what? X such that X is an element of R and X is less than B. So this is open, correct? So here symbol will be
negative infinity comma B.
Or B. Correct? Suppose if it is equal to?
B will have a square bracket.
Fantastic. Correct? So now you can see. So this is what? Semi-open.
Open.
And this is semi-closed. Okay? So, and here you know the same thing will be in an open circle. Okay? So I am not going to the real number 1. Okay? So now let us see about the rules of inequality in real numbers. Okay? That's important. Okay. See, the roots are not very tough. You just take a number. This is very simple. So I am having, let us take any two numbers. Okay, so I am giving you a number. For example, let us say 3 is greater than 1. Okay, if I am adding both the sides, it's some another number. What is that? 3, suppose A plus A or K. If I add both the sides the number, will this symbol cancel valid?
Yes.
You sure?
If it's the same number, it will be
same number.
It will be still valid.
Will be still valid. Correct. Because k equal to 1 means what? 4 is greater than 2. 5 is greater than 2. If I subtract,
It will still it will still be the same.
Still be the same. Simple, na? Because if you say a number line, what happened? You are having 2 points A, another point is B. When you are adding means what? You are shifting it. So you are saying A is greater than B. Am I right? When I add with a constant, that means you are shifting it ahead. Okay, when I am subtracting a constant, I am shifting it backwards. The equality is not going to change at all. On the other hand, suppose, okay, let us say, now I am multiplying with some number, constant. 3 into k. And here it is 1 into k. What tell me? Will the sign be changed? Either this or this.
It will be the same.
It will be same? Sure? Sure?
No, unless it's a negative.
Yes. Got it? So then it reverses. What happened? So if k is greater than 0, okay, then this is valid. If k is less than 0, then it will reverse. Okay. So suppose if you have a greater than b, okay, and you have k greater than 0, ak will be also greater than bk. Okay. On the other hand, if your k is less than 0, then you have ak will be less than bk. Oops, sorry, bk. Okay. So, and so the same way. So now let us put up the condition. So so what we have, so let us write this one is for k, I'm going to make it as a table that makes it easier. K is greater than 0 and k is less than 0. So this is going to be ak is going to be less than bk. Okay. Now tell me one more. Okay. Okay, so this is what here. Again, I am going to have one more. A is greater than B. Okay. A power k b power k. A power k, b power k. Tell me. 3 is greater than 1. 3 power 2 and 1 power 2. Is it still valid?
Yes.
Correct? So it will be same. 3 power minus 2 and 1 power minus 2.
Okay.
That means what? 3 power minus 2 is what?
1 by 3 square.
Okay, 1 by 9. This is 1 by 1 square.
1 by 1. Okay. It won't be reversed.
It will reverse. Okay. So a power k will be greater than b power k if k equal to positive. A power k will be less than b power k if k is negative. This is all what about the equalities, inequality of real numbers. Okay. So, and correct. See, the one of the point is here we are saying, 0. Okay, the condition is A is less than B is than 0, positive. Okay, for these equalities it's okay, it doesn't matter. Okay, so what happened if this one, and if k is greater than 0, what you have, A plus minus k will be either plus or minus, will also be equal to B plus or minus k. Okay, so for k equal to, either k equal to greater than 0 or k is less than 0. Okay, on the other hand, so what do you have? Okay, and similarly, AK will be less than BK if k is greater than 0, and AK will be greater than BK if k is greater than 0. And then the next one is the power, which I wrote it here.
Less than 0 is the second part.
Oops, I made it wrong. Oh yeah, here, correct number, less than 0. Okay. So, and this is what our relations between the inequalities. Okay. So, we can do that. We will do this problem. So what happened? Solve the following inequality. Okay, I am going to give one by one. Inequality. Okay, let us do it as inequality. And write the solution to it using interval notation. We know the interval notation, right? Open, closed, and semi-open and semi-closed. Okay. So we have to write down. So now you can see from here itself, this should be semi, correct? So we will see whether it's semi-open or semi-closed. We will see that. Okay. So how we are going to do this problem? So basically, solution. What we have to do is, we have to get it in this form. Maybe something like x is greater than A, less than B, maybe less than equal to also will come. Okay, so maybe in the closed form or something, we have to get it in this form. So let us see, here it is simple. What we are having, we remember that we saw the rules for the inequalities also, correct? So minus 7 is less than 2x plus 5 less than equal to 9. When they already give this 2 inequality, this is easier because already we can, just with a little bit of jugglery, we will get it easier. Okay, so what happened? You have to convert this into x. So we remember. So first one is, so to convert it into first things, I have to remove this 5. So you have to subtract 5 on both sides. You remember the formula. Okay, when you subtract, add or subtract by any constant k, it is sign, the symbol remains same. Okay, the inequality symbol remains same. Okay, so subtract by 5. So then what happened? Minus 7 minus 5. What it will be? Minus 12 is less than 2x because minus 5 goes on. And then 9 minus 5 is 4. Now we have to remove the 2. So now remember, how to remove the 2? We have to multiply by 1 by 2. Am I right? 1 by 2 is positive or negative? Positive. So the sign remains same. If it is negative, then the sign reverses. Okay. So then this will give you what? Tell me.
minus 6.
Minus 6 because you're multiplying 1 by 2, dividing by 2. So x.
This will equal to 2.
So we got it. So now you tell me, what is the symbol?
So,
minus 6 is open or closed?
closed.
Therefore, the interval is,
Close bracket.
yes,
Minus 6.
minus 6, comma
2 close bracket.
2 square bracket. Okay. So this is the way we have to do it. So when you have these two signs, it will be easier. Now let us take for some other problem, which is slightly where you see here advantage is x is in linear. So it's very easy to get. Sometimes x may not be linear, it may be in quadratic. So then we will be seeing, or in an irrational form, whatever it is. Okay, so we will do that problem on. Okay? Okay, so we will do this problem. So, okay, now let us see here. Okay, what we are having, x square plus 2x is less than 15. So there's only one inequality sign. Okay, and x is quadratic square. Okay, so we can't simply use like earlier we do. So first what you have to do, in such cases, make this right hand side is always 0. Okay, any of right hand side is 0. And then you see whether it is less than or greater than positive or negative. This whole function, accordingly we will get it. The first step is to get it in the quadratic form. So then this will become what? X. So what happened? You have to subtract by 15 on both the sides, right? So what you're going to do, subtract by 15 on both the sides. This will give you x square plus 2x. This is k minus 15. The sign will remain as it is. Okay, so now this is quadratic. Correct? So you can factorize it. Tell me what is the factorization of it?
3 or minus 5.
3 or minus 5. So this will be written as x?
X minus 3 into x plus 5.
Are you sure? Check it. Is it correct? Yeah. Okay. So this one. So now this is, so now if you see, so your x is quadratic. There are x has two conditions. Okay. So either this can be less than, see, so if it less than 0 means this should be negative. It can be negative only, either of them is positive or negative. Okay. So before you can do that, so you have to find out if this is positive, this should be negative, or if this is negative, this should be positive. So this gives you an idea, the interval, get the interval. Okay. The easiest way is, so let us say, for example, take it to 0. When this becomes 0? When x equal to 3, it becomes 0. When x equal to minus 5, this becomes 0. Okay, the first idea is draw the number line. Okay, let me draw it here. Okay, so draw the number line and let us mark the 2 points. So what are the two values we are having? So when x is, so we will, let me write this as, let me write this function p of x, x minus 3 to x plus 5. Okay, so when x is equal to 3, p of x is equal to 0. When x is equal to minus 5, p of x is equal to 0. Okay, so actually there's a, okay, so then what happened? So let me mark down these 2 points here. So this is, let us say minus 5 and let me 3. So basically this has divided your region into 3 parts. Okay. So let this be 1, 2 and 3. Okay. So if I wanted to write your y-axis also, for example. So then it will be what? We have somewhere else maybe 0 where it will be, say somewhere else here will be 0. Am I right? 0 and okay. So now you tell me, so at x equal to 3, p of x is equal to 0 and x is equal to minus 5, p of x is equal to 0. That means this p of x, let me write the p of x along this one. Correct? So p of this is positive and this is negative. Okay, so at these points, they are 0. Now let us see. So now let us take further, see now this is divided into 3 regions, right? 1, 2, 3. and on the points this p of x is 0. So now let us take the left region. Okay, what's the left region? Tell me. X is less than this
less than
minus 5. Okay, in that case, so what should be your this one p of x? Let us take one example, minus 5. So let me take one value, minus 6. Okay, and then when x is equal to minus 6, p of x will be minus 6 minus 3 into minus 6 plus 5. Correct? So this will be how much?
9.
Minus 1, 9, right? So 9, that is greater than 0. So that means if you see here, so this region, this will be greater than 0 above. Okay, so this is what technique is called as the wavy technique. Okay, so this region, all this region, this is going to be positive. Okay, now let us go for this region. Maybe let us go for the last region. So that is what? X is equal to
3.
x is greater than 3.
Greater than
Correct, this region we are taking. So let us take when x is greater than 3. Tell me a point.
X is equal to 4.
4. Okay, so then p of x will be equal to what?
4
4 minus
minus
3 into 4 plus 5 equal to what? 4 minus 3 is 1.
4 plus 5 is
9 greater than 0. So that means here also this goes to 0. Okay, so this is going to 0. So now let us take the value intermediate value. Okay, so what will be the intermediate value?
X is less than 3 and greater than minus 5.
Now first you have to write x greater than minus 5 less than 3. Okay, so tell me a value. So let x be
minus 2.
okay, minus 2. So in that case p of x equal to what?
Minus 2 minus 3
minus 2 minus 3 into
minus 2 plus 5
plus 5 equal to how much?
minus 5 into minus 5 into 3
equal to
minus 15.
Is that correct? Less than 0?
That.
Right here, right? This is less than 0. Okay, so then your line, so this region, this is negative. Okay, you can take out 2 more points also if you want. Okay, we'll say always it is negative. So then this will be something like this. Am I right? So then our required region is what? Tell me, what will be the required region? The valid region? Because this is the condition we want, right? So we have to take this thing has to be this p of x. P of x is this, right? Has to be less than 0. So p of x is less than 0 only in this region, second region. And this is less than 0. So therefore, since it's less than 0, so these intervals are closed or open?
Oh, sorry, open.
Open. So it will be a circle. Correct? So it's not closed. So because it is less than. Right? Therefore, the interval is minus 5, comma 3. Correct? This is what your answer is. Okay? So let us do one more problem. Some more problems. Okay? Okay? Let us do this problem. Okay? The answer for this problem in your book is wrong. They give a solution, but that solution is not correct. Okay? So we will correct this one. Solution. Because whatever the range they given, if you put, this will not be satisfied. Solution. Same thing. So now it is not in a quadratic. It is in a more in the fractional form, right? So what you have to do? X divided by x minus 3 should be greater than or equal to 4.
We have to subtract by 4.
Yeah. See, the first thing is you may think, okay, let me multiply by x minus 3 on the both the sides. Okay. So what you will see, you x minus 3 you will multiply from both the sides. So you are going to, one way you can think about it is, so you are going to multiply x minus 3 on both sides, then you will have x into x minus 3. Okay, and here 4 into x minus 3. You don't know what's,
The LHS, it would be x into x minus 3.
Oh, sorry.
It will only be x.
One will be x. Yeah, right. So what happened? So we are going to have x minus 3. Okay. Now, is it like this or this? That depends upon what is the sign of x minus 3, which you don't know. Okay, because x is the value you want to find out. You don't know what is the interval of that. You don't know. So this is not the right way of doing. Whenever there's an x term is there, don't try to multiply that term. You should never contain x there because x is unknown quantity. So this is not a right way of doing. So rather we have to look for another way of solving it out. So the same thing, what I said. So let us solve it as it is. The step is to take the right hand side 0. Correct? So it means you have to do subtract by 4 on both sides. Subtract by 4. Okay. That means what? X divided by x minus 3 minus 4 then equal to 0. So now tell me what it will be. Take out x minus 4x plus 12 divided by x minus 3 then equal to 0. So this will be what? Minus 3x plus 12 divided by x minus 3 equal to 0. So let me take one minus 3 commonly outside. See, remember, always don't take, let the x should not be negative. Try to make it always positive. Okay, so when if I take minus 3 commonly outside, so the x becomes positive. Correct? And x coefficient should be 1. Don't make it any factor. Okay, so to make it 1, what I have to do? I have to take minus 3 outside common. So then this is what happened? Minus 3x minus 4 divided by x minus 3 greater than or equal to 0. Correct? So now let us see. So now we have to remove this minus 3.
Multiply both sides by 1 by 3.
1 by minus 3. 1 by minus 3, right? Multiply, yes, multiply by 1 minus 1 by 3. So it is less than 0. So the sign will reverse. So this is going to be x minus 4 divided by x minus 3 is less than or equal to 0 because you're multiplying with 0, it means 0. Okay. So let me call this one as p of x is equal to x minus 4 divided by x minus 3. Okay, so now again we can see there are two cases. Two cases it becomes 0. What is that? When x is equal to 4, p of x will be equal to 0. When x is equal to 3, p of x should be equal to how much? 3 minus 4, right? That is minus 1 divided by 0 minus infinity. Correct? So if you actually see, both the conditions satisfy. This also satisfy. Okay, of course, minus infinity, it satisfies, but it is not a closed one, right? It is open. Infinity we never. Because all it says is, yeah, naturally you shouldn't include this. Because this can be...
Doesn't come, if you include it, it won't be less than or
correct.
equal.
When it goes to 3, it shouldn't reach 3. So 3 can be open. X equal to 3 can be a open point. Okay, so this is not right. So let us draw it in the number line. So let us draw the number line. So what we are going to do, so again, so how many points we are having? X is equal to 4 and x is equal to 3. So let us make here 3 and here 4. Okay. So now let us see. So remember, now it is interesting. So at x is equal to 4, our point is 0. Okay. And x is equal to 3, our point is minus infinity. Okay. So from here itself says this goes from 0 to minus infinity. Okay. And let us see about these regions what will happen. So, okay. So now let us take within the, so again this is divided into 3 regions. 1, 2 and 3. Okay. So 1, 2 and 3. So let us take this one. So let us take for the region 1. Tell me what will be the region 1?
X is less than 3.
X is less than 3. So let us take a value. x is equal to
Equal to 2.
2. Fine. So what will be p of x? Tell me.
2 minus 4 divided by 2 minus
2 minus 4 divided by 2 minus 3. Tell me what this value?
2 by 1. 2.
Minus 2, na? Minus 2 by minus 1, that will be equal to 2, right? That is greater than 0. So that means this region, okay, okay, because at 3, 2, this is greater than 0, right? So from minus infinity, okay, from there it goes into the plus infinity and then it goes something like this. Because at 3 it goes to infinity, correct? So if you actually see what happened, if you try to increase it, it will decrease. So for example, take another one point, x is equal to less than 3, right? Take it 1. Tell me what will be p of x?
1 minus 4, that will be minus 3 divided by minus 2. 3 by 2.
Plus 3 by 2, correct? That's also again greater than 0. Now you see it's reduced. So as you go away, it reduces, right? So this will be a positive, but only thing is goes from 0 to infinity, something like that. You don't have to draw this line. Only thing you have to remember. Okay, so at this region, this is infinity. Okay, so this type of way of solving is what they call the wavy method. Wavy method or something. Okay. Anyway, it doesn't bother about what is the method name. You know how to get the interval. That is important. Okay. And okay, so this is the region 1. Am I right? So now let us go for the region 2. Okay, good. So the region 2. Where will I write the region 2? Fine. So let me write the region 2 here. What is the region 2? X is greater than 3, less than 4. Tell me now this region. Okay, good. X is equal to 3.5. So what will p of x? Tell me.
So 3.5 minus 4, that will be minus 0.5.
Minus 0.5 divided by 0.5. So this is equal to minus 1. So minus 1 is less than 0. That was the condition we have to do it. Correct. Okay, so that means yes. Okay, at 4 it becomes 0. Okay, so this goes something from 0 to something like this. Am I right? Okay, and then comes third region.
X is less than 4.
X is what? Less than 4? Greater than 4.
Oh, sorry, greater than 4.
X is greater than 4. Okay, tell me what's the value of x? Trial value 5. So p of x will be
1 by 2.
1 by 2. Correct? That is greater than 0. Alright? So this is going to be, so let me write it down. Yeah. So it goes like this. Okay? So here this is the 1. So this is 4. Okay? Now which is the region for us? Tell me. So we have to get it. Condition should be p of x should be less than or equal to 0. This is out of question. Okay, this won't cross here. This should be always goes to. I should write like this. Okay, it don't goes to 0. Okay, so this is out of question for us. So, and these two are positive. So that won't work. Okay, so for us only the thing is, this is the region which works. Now tell me. So there are two limits we got. Which one is the closed and which is open? 4 is what? Closed. Because 4 is 0. Of course, less than 0 is there. So 4 is closed. What about 3?
It's open.
Open. Minus infinity, right? So 3 has to be open. Therefore, the interval is what?
Curve bracket 3.
Is
Curve bracket 3.
3,
And,
comma
4 square bracket.
Got it? This is how this problem. Okay, in your book it is written wrong. Okay, I know because the book what they have said is something different. Okay, that won't help here, work here. Okay, so now let us take two more problems. Okay. Let us do this problem solution. How will you do it? Tell me. This will be what? X square minus x is greater than 20. Okay.
Subtract 20.
Right answer is to 0. Subtract by 20. Okay. So this will become what? X square minus x minus 20. You are subtracting, so the sign is not going to change. 0. So again, it's a quadratic. Factorize it. Tell me.
Okay. I'll use quadratic formula.
Use quadratic formula.
Five or minus 4.
Correct. So x minus 5 and x minus 4. Okay. So again, so the same way we got it, right? So now this is this should be greater than 0.
Two critical points.
First, 2 critical points. Exactly. You can call it as a critical points. Okay. So 2 critical points. Okay. Yeah, you can use that word. I didn't use it. Just right. You can use the critical point. So what happens? So we are going to have x is equal to 5. So when x is equal to 5, okay, the first thing is we have to mention, write down as a p of x, right? So let p of x be equal to x minus 5 into x plus 4. So let us add that value where this becomes 0, this point where. So x is equal to 5, p of x is equal to 0. X is equal to minus 4, p of x also equal to 0. Of course, this 2 is out of the, because it is greater than 0. Okay, so now, let us again draw the number line. Okay, so in a number line, what will happen? Let us draw it. So we will take what are points? Minus 4 and 5. So maybe here minus 4 and here it is 5. Okay. So now let us go again. It is divided into how many regions? See, it is not necessarily 3 regions. Sometimes you may have one more factor denominator.
If it's a cubic polynomial.
Correct. Then it will become 4. Or if the whole thing, I am saying the whole thing is divided by some other number. You got it? Some x minus 3. That case also, then you have 3, 4. It won't divide into 3 regions. You divide it into 4 regions. For each region, you have to identify. And see which region, whether it is going to greater than 0 or less than 0. Greater than 0, less than 0. And you have the condition. And see which one is going to satisfy. And that's how the thing you have to do it. You got it? So let us take the point. So this is, okay, this is divided into 3 regions. 1, 2, and 3. So let us go by, anyway, at these points we found that is 0. Okay, unlike in our earlier problem. At 3 it went to minus infinity. Okay, so let us do this problem. So let us take for the region 1. What is region 1? Tell me. X is less than minus 4.
Minus 5.
So let us take x is equal to minus 5. So in that case, p of x equal to how much?
Minus 10
minus 5, minus 5, minus 5 equal to minus 10 into minus 1 equal to 10, which is what? Greater than 0. Okay? So that is positive, correct? So that means here it will go like positive. Am I right? So now let us go for the region number 2. Okay? What's the region 2?
X is less than 5.
X is greater than minus 4
less than 5.
less than 5. Okay? So let us take. So tell me value. X is equal to minus 2. Fine. So p of x equal to what?
Minus 7.
Minus 7 into 2.
Minus 14.
Minus 14 less than 0. Negative. So in this region, so this is going to be something like this. Correct? And then let us go for the third point. For the third region, x is greater than 5. X is equal to
6.
6. Okay, fine. So p of x equal to what?
1
1
into 10.
10, right? So it is equal to 10. greater than 0. So this again goes to greater than 0. What is the condition required region we have? Tell me.
Positive.
Yeah, this has to be positive. This is the condition we wanted it, right? See here. It's not less than. If it is less than 0, of course, we would have got this domain. But here what we are demanding? Greater than 0. Therefore, this is not the one. These two are the domains. Okay? You got it? So now, tell me, what is this domain is? So this is a open or closed? Tell me. X is equal to minus 4, PF is equal to 0. So PF 0 is not allowed, right? So this has to be open. Okay, so this also has to be open. And similarly for 5 also, it is 0. They both are open. Okay, so this region is something, if you see carefully, so this region is something, it has an open interval at minus infinity, very positive, correct? To minus 4, again open. And this region will be
5
open to infinity. If you have to combine these two, what do you do? Union.
Okay.
Got it? So therefore, that means you combine these two. That's a union. Now you join, right? So therefore, the interval is minus infinity, comma minus 4, union 5, comma infinity. Got it? Let us do one more problem. With that, I will stop. Okay? Okay? So this problem is
Similar to that one.
correct. So this problem is similar to the earlier one we did, but it will come out to be slightly different. We never know because in inequality how it is going to. But we have to proceed in the same way how we did earlier. Correct? So let us do the solution.
Separating by 5.
Exactly correct. First step is, what is the problem? 2x divided by x minus 4 less than or equal to 5. Subtract by 5. Correct? By 5. Okay. So what it becomes? 2x divided by x minus 4 minus 5. Here should be less than or equal to 0. Subtraction of the sign won't change. Okay. So what this will be? Tell me. 2x minus 5x plus 20 divided by x minus 4 equal less than 0. So we take what will be minus 3x plus 20 should be equal to x minus 4 to 0. Okay. Now I said the coefficient of x should be always 1, not even minus 1. So you have to take minus 3 commonly outside. Correct? So if I take minus 3 commonly outside, this is going to become x minus 20 by 3. Okay? Divided by x minus 4 is less than or equal to 0. Yeah, now tell me. We have to correct, multiply by minus 1 by 3 on both sides. Okay, so the sign is going to reverse. So we are going to have x minus 20 by 3 divided by x minus 4 should be, of course, 0 into anything is going to be 0. So greater than or equal to 0. Again, so we have two regions, right? So where is that? X is equal to, when x is equal to 20 by 3. Okay, now first we have tried what? P of x. P of x is equal to x minus 20 by 3 by x minus 4. Let us take the critical points. Critical point is whenever these values become 0. Correct? So the first critical point is when x is equal to 20 by 3. So P of x is equal to 0. Okay? And second case is x is equal to 4. P of x will be
4 minus 20 by 3. That is like 18 by 3 is 6. So
tell na, simple. 4 na. 4 minus 20 by 3 na. So 12.
12
Ah.
minus 20. Minus
Correct.
6 by 3.
How
Minus
much?
8 by 3.
Minus 8 by 3. Correct. So this is minus 8 by 3 divided by 0. So will this be?
Negative infinity.
Minus infinity. Okay. So of course it won't satisfy that. Okay.
F will be open.
And now, so anyway, so we are having again the 2 critical points. Let us now draw the number line. Okay, we are going to draw the number line. So let us draw the number line. So there are 2 points, correct? The lower point is 4, correct? Yeah. And this one is 20 by 3. Okay? And this is divided into 3 regions. 1, 2, and 3. Okay? So let us do one by one. So region 1, tell me. Region 1, x is less than 4. So let us take x is equal to 3. Okay? Or 2, which one you want?
3. We can take 3.
Okay, so x is equal to 3. So if x is equal to 3, p of x will be equal to how much?
First 3 minus 20 by 3.
9 minus 20.
Minus 11.
Minus 11 by 3. Am I right? Minus 11 by 3 divided by
1.
minus 1.
If x is equal to 3, right? So, okay, right.
3 minus 1, na?
11 by 3.
Is equal to 11 by 3. This is greater than 0. Okay. So we got the satisfy the condition. Yeah, let us see. Okay, so that is positive. That means this region goes something like this, positive. Now let us go for. Oops, sorry, I made a mistake. Nah.
4 will be in infinity.
Yeah, 4 will be in the infinity. So this will be go something like this. Okay. Okay. Now let us go for the region number 2. What is the region number 2? Tell me.
X is less than 20 by 3. X is greater than 4.
4, eh?
Less than 20 by 3.
Tell me.
So we take 5. So
P of x will be equal to
15 minus 20 by 3. That will be minus 5 by 3.
minus 5 by 3, right? Here above, right? Minus 5 by 3
Divided by
1.
1.
So it's minus 5 by 3 only. That is less than 0. So this will be,
Invalid.
yeah, 20 by 3, this is 0, right? So this goes like this. 0, na?
0 to infinity.
Correct? Something like that. Okay? In the exam, you don't have to draw this line. Okay? Just make this line points and write the 2, 3 points. Okay? I'm drawing this plots for your understanding. Okay? But you write this way. Okay? Region 1, region 2, region 3. Okay? And then we are going to the last region, that is region number 3. Tell me, what is region number 3?
X is greater than 20 by 3.
X is greater than
20 by 3.
20 by 3. So let us take a value. Simple, x is equal to 21 by 3. It's greater, na? Tell me, what is P of x?
P of x will be equal to
21 by 3.
7. 21 by 3 is 7.
Why do you want to do so? 21 by 3, na?
Okay.
1 by 3, that is.
1 by 3.
1 by 3 divided by
7 minus 4, that will be 3.
7 minus 4, that will be 3. Am I right? Positive. So that's equal to what?
1. 1 by 3 divided by 3, no? Okay.
1.
I can say double.
1 by 3 into 3 by 1, na? Of course. 1 by 9. This is what? Greater than 0. So that is positive for us. Correct? So this will go something like, maybe positive goes something like this. Correct? So this won't be a break, it will be continuous functions. So anyway, for me, I'm just drawing like that. So tell me. So which are the regions? So what we want to have? P of x has to be greater than or equal to 0. Okay. So here this is, okay, first and this third region. Now tell us, find out the intervals, closed and open intervals. 4, when it is 4, minus infinity, open, correct? So this is a open. What about 20 by 3? 20 by 3 equal to 0? Yes, of course, equal to 0. So this will be a closed. Correct? So therefore, the interval is
minus infinity.
So this will be what? Minus infinity.
Close bracket.
Yes.
Minus infinity.
Not a closed bracket. Parenthesis. Comma
4.
4. 4 also should be
Curved bracket.
curve bracket. Okay. Union. Yeah.
Closed.
Oh, sorry. This will be closed square bracket, right? Square bracket of 20 by 3, comma, infinity.
Curved bracket.
Got it? And this is how you have to get the intervals. Okay? Okay. With that I stop. So tomorrow there are so many exercises. You have to do all the exercise problems. Okay?